Hey folks, welcome back. We are talking about dynamics. We're looking at general plane motion, and here we have a drum example, and I just want to show you. So I drew this one, right? This my handiwork, and it's a little bit lumpy. It came from this example that I found, and I prefer to use my own drawings. You may disagree, you may prefer this one, so if you do, I encourage you to take a still of it right now, but I'm going to use my own. Any chance I get, I try to draw my own, even if it's crappy, and the reason I do that is because I understand my own words better than I understand somebody else's. So, as promised, this conversation about the instantaneous center of rotation has a second component to it that I think is pretty cool. So if we have some sort of a general object, right, some sort of random object, we can define point A and point B, right? So we'll call this A. Hold on, our thing is red, so let's pick a different color for the inside stuff. Here we go. We'll call that A. Have some fun with it, right? Bust out the big crayons. All right, and B. And what we talked about before was this idea that if we have various velocities, then we can go normal to those velocities and define some point C that allows us to quickly define the angular velocity of the object, right? So a very interesting situation arises when the velocities are parallel, right? So if you can imagine B is like that and A is like that, then what we can do is we can still define this point C up here, right? And C is there, and then it would be between the points, but also it connects in a way that forms like a similar triangles idea, which is super cool and useful when we're dealing with stuff that is circular, or really any time that the velocity of A and the velocity of B are parallel. And a classic and very useful example of this is in wheels, right? So if you can imagine, we have a wheel. We're not going to have to imagine for long, right? Because, you know, that over there. But if you have a wheel, the wheel is not moving. Even if we have a velocity here, we'll call this O, even if you have a velocity here, then it is rolling, right? So the center axis is traveling, but the point that makes contact with the road, that is not moving, right? Well, we assume not, right? Maybe it's sliding, but we would have to think about that. But in this case, it's not. So what that means, by extension, is that we can just create this triangle that allows us to find that all of the points along this wheel from the center to the lower surface here scale with that, right? And so the entire thing can be thought of as a situation of similar triangles based on this instantaneous center of rotation idea, right? And this is the concept that we're going to use to solve this system, which I think is pretty cool. And once you get it, it's sort of one of those fun things in dynamics that, you know, we get to play with the geometry again, and it's kind of fun. So our situation is that we are given this physical system, this, you know, back to my bad drawing, and, you know, this is the good drawing, but we're not going to use that. We'll push that to the side. So it is a two-stage drum. And there's a cord where it's purple here. There's a cord wrapped around the inner portion of the drum that is a radius of 3 inches, and the cord is being pulled this way at a rate of 6 inches per second. The outer drum is on the ground, and that is our system. we're asked to find first the angular velocity, then the velocity of A, right, so the center there, and then the velocity of the cord that's either being wound or unwound, right? So let's do it. What are we going to need? What equations do you think that we're going to need to solve this? I recommend just pause the video, pause, right? And then I will walk through it. So let's see, pause. 5, 4, 3, 2, 1. Okay. All right. So hopefully you paused it. I am pretty convinced that we'll be able to use some similar triangles and maybe this, right? So maybe V equals omega cross R. I think we can do most of what we need to with that. All right. So first things first. Let's draw our thing the way that I just did, right? So here is D, right? And we're given this V sub E, right? That goes that way. And this is calling this V sub E, right? And so what we end up with is something like this, right? And that kind of necessarily means that if this triangle is going to work, then A has to go that way, right? So this is VA, right? And then we have these distances, and let's see, what is this? This to this, so it's 3 going this way, 5 total, so this is 2. And then this is 5. Okay. All right, so we have our diagram here that gives us our graphical representation of this system as we're going to need it. And for A, we want omega, right? So from here, we say, well, omega is just V over R, right? Okay, well, let's see. R implies from the center. We have V sub E, right? So 6. So this looks to me like it's going to be 6 over 3, right? So omega equals 2 radians per second, right? And if we are translating this way, VA is bigger, then it is going to be, let's see, it's going to be rotating like this, right? So let's say in this direction. All right. B, hey, you know what? Let's switch pens. All right. Okay, so for B, we're asked to find V sub A. Well, we can use this relationship here, right? Because these are similar triangles. So what we can say is that VA over 5 is equal to VE over 2, right? Just similar triangles, that's all it is. So then VA is, did I write that right? I think I did. I think so. Yeah, I'm sure I did. All right. So this gives us VA is equal to 5 halves. And what is VE? VE is 6, right? So 5 halves of 6, right? So this reduces to 3, and then we get the VA is equal to 15 inches per second. And that is going in this direction. Okay, all right, so this is B, and we can circle this. All right, now we'll go back and, since we're having fun with crayons, why not? I guess these are whiteboard markers. I've been listening to too much rap music or something. All right, there we go. Okay, so that's A, B, let's do C in orange, because why not? All right, so for C, we're saying, are we winding or unwinding? That's actually a really good question, right? So the center velocity is going at 15 this way, and the velocity of E is going at 6 this way. So then we are winding cord, right? So how would we say that? We would say, well, because, okay, so we would try to write it a little more neatly. So we would say because VA is greater than VE. We're winding. Okay, and how much? Well, it's actually simpler than you would think. All we do is we say, well, VA minus VE is the amount that the rolling is overcoming the velocity of the cord, right? So that is our V. This is what, 15? This is 6. So that is going to be 9 inches per second that we are winding, right? And that is V, so we'll say that equals V. And there you have it, right? Pretty straightforward. I think that's a fun problem. It's not, there's certainly not a lot of cognitive or conceptual challenge to it. And, in reality, I think this kind of goes the other way, right? So when we use this concept, then it sort of makes this a lot easier to attack. So I hope that was helpful. I hope you enjoyed it, and I will see you in the next video.